So 2x minus 1 divided into negative 4x cubed minus 8x squared plus 7x minus 1. Now, I first need to get rid of the cube, then I get rid of the square, then I get rid of the x. Since this is a x to the 1 power, I'm not done until I have a constant. Oops, I almost forgot. So what do I multiply 2x by to get negative 4x cubed?
Negative 2x cubed.
Negative 2 squared, right.
Sorry, yeah. Squared.
Negative 2x squared times positive 2x, negative 4x cubed, negative 2x squared times negative 1, positive 2x squared, and then you subtract. Minus changes to a plus, plus changes to a minus. I got rid of the cubes. So it's kind of like 1 down and 2 to go. And minus 8 and minus 2 is minus 10x squared. Now you bring down the plus 7x. What do I multiply 2x by to get minus 10x squared? Minus
5x.
Minus 5x. Minus 5x times positive 2, negative 10x squared. That's going to kill off the x squareds. Minus 5 times minus 1, plus 5. And then what do? Subtract.
Shouldn't there be an x there? Yeah. You just said plus 5. You wrote
and
x.
Changes the signs. Right? I now killed the x squareds, and what I'm left with a positive 2x, and bring down the minus 1. These all divide evenly. That's kind of interesting. I didn't choose them. Now, I'm not done. And you say, well, why aren't you done? I have a degree 1 here and a degree 1 there. I'm not done. I still need to kill off a degree 1. Because my remainder has to be degree 0. So I keep going till I get a constant. So for you guys, you're going to keep going till you get a constant. Yes?
The flipping the sign thing is confusing. I don't know. Sorry.
Subtraction flips the signs.
Okay.
Even if you were doing regular long division, you would subtract, which flips the signs. Now, synthetic's a whole different animal. Synthetic's a whole different animal.
Like, for instance, in the last problem, it was negative 17 minus negative 10x. It wouldn't be negative 27. It would be negative 7. I don't know.
Yeah.
Okay.
Because negative 7, I'm sorry, positive 5 times negative 2 is negative 10.
Yeah.
Then when you subtract, subtraction means add the opposite. That means that if you're adding the opposite of a positive 5, it's going to be negative. If you're adding the opposite of a negative 10, it has to be positive because you're subtracting. That's the old change the sign thing that we don't like so much.
Okay, so it would be plus 1 because 2x goes into 2x one time.
Correct. So this would be a plus 1. Hopefully I'm on the screen. I'm not. And so 1 times 2x is 2x. 1 times minus 1 is minus 1. And then again, add your subtracting. Now here's another way of looking at the subtraction thing. That says you're subtracting what? That whole thing.
Yeah.
And what happens if there's a minus out instead of a side of a set of parentheses? Changes the signs. This 2x changes to a minus, and this 1 changes to a plus. And then, of course, you're going to end up with 0 again. So then you're going to have an answer of negative 2x squared minus 5x plus 1. Long division. Any questions on long division? Just going to take some practice. Once you do it a few times, you should be in good shape. If not, that's why I want to give you some questions as you're working through the homework, the supplemental homework. I don't want to call it regular homework. The supplemental homework. Then at that point, you can ask questions, and we can try to get this straightened out.
So
Where you're having problems. Yes.
So the first term is always divided, and that is brought up as the answer. The
Yeah.
second term is multiplied, and that's what you reverse the signs. Like 2x times negative 2x squared is negative 4x to the
Correct.
third.
Correct.
So you multiply the second tier,
Correct.
divide the first term.
Correct. Yes.
Okay,
Yeah.
I think I understand now. Okay.
Yeah. I mean, it's a lot like regular division. If I were to take, say, 15 and divide it into, say, 172, right? 15 goes into 17 once. Then what do you do?
15.
1 times 5 is 5. 1 times 1 is 1. And then what do you do? Subtract. Then you bring down the next one, right? 15 goes into 22 once, right? Then again, 1 times 5 is 5. 1 times 1 is 1. Then you subtract. Because it's a positive 15, you change it to a negative 15. That gives you a 7. So your answer is 11 you could write it as a remainder of 7, which is not what we do in arithmetic because it looks kind of icky, right?
Yeah,
Or we'd write it as 11 and 7 divided by 15. With the remainder divided by the divisor. Algebra is no different. Right? That's why when you come back over here and you say, what do? You know essentially what's going to get rid of it, but then what do? You take negative 2x squared times positive 2x, that's negative 3x cubed, negative 2x squared times positive 1, that's going to be negative 2x squared, and then you do what? Subtract. That's exactly what you did here. 1 times 5 is 5. 1 times 1 is 1, then you subtract. So the process is the same.
Yeah, that's much better explained than what I learned in grade school.
And besides, we don't remember what we learned in grade school.
Well,
it was too long ago.
I remember a lot of it.
Yeah, but that's kind of like algebra is the reason why algebra is very closely related to the arithmetic. And you're going to say, well, why is that? Because if you give me a value for x, that turns into a number. So in this particular instance, if x is 10, I would say 2 times 10 is 20. 20 minus 1 is 19. I'm dividing by 19. If x is 20, if x is 10. And if x is 10, all of these things would combine to be a number. So I'm doing arithmetic. So it's got to follow closely the rules of arithmetic when you're doing algebra. That's why the divisions are so similar. But we're not used to quite handling them the same way. But it is very, very much the same. So any more questions on long division before we move on? You got to get in and get your hands dirty. So that means that right now that's what your focus is going to be, because you know you're going to be tested on it. So, and you can choose to take the grade you have, but I think most of you will not want the grade you have. And those of you who are saying, I didn't actually do too bad, think about what the extra points will do to your current grade. So synthetically divide. Now remember, that's then looking at doing not long division, which that would be this guy. And then taking it as a shortcut. You can do it long division, don't have to do synthetic. But I, as myself, did all my algebra work using long division, everybody else using synthetic. I'm sitting there 5 minutes working a problem, and they've got the problem done in one. So I better be very, very fast at everything else, right, on a test, if I'm going to try to do everything long division, because everybody else is just whipping through, and I'm sitting there multiplying stuff out, where I should have been using synthetic, because I chose not to learn synthetic. It was just me. I appreciate it now. But then it says, do I have to use synthetic division? Same question you asked me. I chose not to. But that means I had to be faster on my test in other places where people just would work through. They had all those minutes. I was wasting them doing long division. So, here we go. So now remember how this works. At this point, I write an equivalent problem. I just write the coefficients, x squared, -4, -45. It matches up with all of those x things. So I don't have to subtract anymore. I change that +5 to a -5. That takes care of change the sign. Because what did I do in the very beginning? Change the sign. And that's what makes synthetic division work. I can't do it in the long division problems because there's too much attached to it. But I can do it in synthetic. So now the sign's already been changed. So you bring down the 1. So remember, -5 times +1 is -5 and add. -5 times -9 is +45 and add. Now again, these guys are, I didn't write the problem, so they look like that they are dividing evenly. This is the remainder. Always start from left to right. The remainder, the constant in my answer, and x. So my answer ends up being x minus 9 with a remainder of 0. He has no remainder. That's synthetic. But it only works when what you're dividing by has 1 as its coefficient. If it doesn't have 1 as the coefficient, that's long division. Again, this is x plus 4 divided into -2x cubed, if I were going to do it like me in school. And also, because I'm doing a representative thing, all powers have to be accounted for, and they are. If I'm going to set that long division up as a synthetic division problem, I'm going to divide by -4 so I don't have to change the sign on anything. X cubed, x squared, x constant. That's why all the powers have to be accounted for, because everybody matches up with the guy that's above him. And if somebody's missing, you're going to be off. It's like the difference between 1,000 and 100, just a missing 0. But wouldn't you rather have the $1,000 than the $100 if offered? I mean, it's only missing a 0. So here we go. Start off with the -2. 4 times -2 is +8, and add. -4 times +2 is -8, and add. -4 times +6 is -24. Every single one of these divide evenly and add. Now, how do I write it out? Start there. That's the remainder. Guy at the end's always the remainder. That's your constant. That's x. That's x squared. So the answer comes out to be negative 2x squared plus 2x minus 6. And if I had a remainder, I would put r, whatever that number is. But I don't. I just do this. I would do something like that if that were something other than 0. 0, I don't have to write it. Because in college algebra, by the way, sometimes you're interested in the remainder, and sometimes you're interested in what you got from the division, which is the quotient, and sometimes you're interested in the whole thing. Depends upon what you're doing with it. Any questions?
Yeah, the thing I just realized is that you don't have to change any of the signs.
Correct. Because I changed
you already changed.
Because I already changed the sign, yeah.
That's what I just realized.
Yes.
How'd you get a negative 6?
Yeah, I got a positive.
Yeah,
Oh,
I got
that should be a
that
positive 6.
Yeah.
Because I was looking at the negative 8. At least that's anything that's wrong. Did that help?
Yes.
Did it? Good. We'll see. Whoops.